Geometry checkpoint 2, systems of equations. When two equations are both in y equals mx plus b form, it is convenient to use the equal values method to solve for the point of intersection. Set the two equations equal to each other to create a single equation in one variable, then proceed to solve for x. If one equation has a variable by itself on one side of the equation, then that expression can replace the variable in the second equation. This creates an equation with only one variable. This is called substitution. If both equations are in standard form, ax plus by equals c, then adding or subtracting the equations may eliminate one of the variables. Sometimes you'll need to multiply one or both of the equations in order that the coefficients are the same or opposite. This is called elimination. Sometimes the equations are not convenient for substitution or elimination. In that case, one or both of the equations needs to be rearranged into a form suitable for the previously mentioned methods. So our first example is solve the following system: 4x plus y equals 8, and x equals 5 minus y. So right off the bat, you should realize we're doing substitution. We've got x by itself, and we're saying x is the same as 5 minus y. So I'm going to take my x, and since it's equal to 5 minus y, I'm just going to replace the entire x with the entire quantity 5 minus y. So I have 4 times the quantity 5 minus y plus y equals 8. And again, we're just replacing everything. We're taking this whole x, and we're saying it's the same as 5 minus y. So I'm replacing it all with 5 minus y. So the first thing I'm going to need to do is distribute. 4 times 5 gives me 20. 4 times negative y gives me negative 4y. I'm going to bring everything else down, so just plus y equals 8. Now that I only have one variable, I can go ahead and solve the way I'd solve any regular equation. First thing you're going to want to do is combine your like terms. Negative 4y plus y is going to be negative 3y. I'm going to bring everything else down. So I've got an equals 8 over here, and I've got a 20 over here. So the next thing I need to do is I want to get my variable by itself. And I'm going to do that by first moving my constant over. So since I have a positive 20 right here, I'm going to do the opposite, which is subtract 20. 20 minus 20 is 0, so it goes away. I'm left with negative 3y equals 8 minus 20 is going to give me negative 12. So the next thing I need to do, I have negative 3 times y. In order to get y by itself, I'm going to divide, since the opposite of multiplication is division, by negative 3. My negatives 3 cancel, leaving me with just y. Remember, negative 12 divided by negative 3, a negative divided by a negative is going to be a positive 4. Now, we're not quite done yet, because we still need to find our value for x. So we know that y is equal to 4. We need to go back and find x. So what we're going to do is we're going to take y equals 4, and we're going to substitute it back in order to solve for x. So I have x equals 5 minus 4. So 5 minus 4 gives me 1, so I know x is equal to 1. So I think 1, 4 is going to be my solution. Now obviously I want to make sure that this works, so I'm going to plug it back into my first equation. So I have 4 times 1 plus 4 equals 8. 4 times 1 is 4, and 4 plus 4 is 8, so it works for that one. For my second equation, I've got 1 equals 5 minus 4. 5 minus 4 is 1, so it works for the second equation. So I know this is my final answer. I can go ahead and circle it and go on to the next one. It's important to make sure you always go back and check your work with systems of equations. because sometimes you'll make a mathematical error in the first part, and when you go back and substitute both of them back in, that's when you'll find out where your error is. So let's do another one. So for my second one, negative 2x plus y equals negative 7, and 3x minus 4y equals 8. Now, if you prefer substitution, you could add 2x to both sides and then substitute positive 2x minus 7 in for y in the second equation. However, I'd like to show you an elimination problem. So instead what we're going to do is we're going to multiply this entire top one by 4. Now, a lot of you at home are probably sitting around and wondering, how do I know to multiply by 4? You actually could have multiplied by several different things. You could have done the top one by 3 and the bottom one by 2, which would give you 6x, negative 6x, and 6x. So that way you'd eliminate your x's. The reason I wanted to go with 4 is because I have a negative 4y right here. And so if I multiply 4 times y, I'll get 4y, which will eliminate my y's when I multiply. But again, you could have solved this with substitution. You could have solved this by multiplying the top by 3 and the bottom by 2. You'll still wind up with the same answer. So now we have to remember, you need to multiply everything by 4, otherwise your equations won't work. So I've got 4 times negative 2, which is going to give me negative 8x. I've got 4 times y, which is going to give me positive 4y. And I've got 4 times negative 7, which is going to give me negative 28. For my other equation, since these are going to have the same coefficients, I'm just going to bring everything down. So 3x minus 4y equals 8. Some of your algebra teachers may have taught you that you want to multiply this by negative 4. That way you can, actually 4 works for this one. Sometimes you'll wind up with a negative 4 and a negative 4. When their coefficients are the same, that's when you're going to want to multiply by, But since this one we have a positive 4 and a negative 4, we're just going to leave it as is. So, what I want to do, since I have positive 4y minus 4y, we're going to add both of these equations. Negative 8x plus 3x is going to give me a negative 5x. We've already talked at length. 4y plus negative 4y is 0, so it eliminates my variable. And then over here, negative 28 plus 8 gives me negative 20. So the next thing we need to do is get x by itself. So we've got negative 5 times x, that's what this means. So we're just going to divide both sides by negative 5. When I divide both sides by 5, my negative 5's cancel out, giving me x equals 4. Now, just like with the previous example, we're going to need to take x equals 4 and substitute it back in order to solve. And I'm just going to go ahead and erase this so we can see better. So again, I'm going to take my x equals 4. You can plug it into either equation. It really doesn't matter. I'm going to plug it back into the first one just because I like the first one better, but there's nothing wrong with plugging it into the second one. So I have negative 2 times 4 plus y equals negative 7. And now we're going to solve for y. Negative 2 times 4 is going to give me a negative 8 plus y equals negative 7. I'm then going to add 8 to both sides. Negative 8 plus 8 cancels, so I'm just left with y. And then negative 7 plus 8 is going to give me a positive 1. So I think the solution for this equation is going to be at 4, 1. But just like with the last one, I want to take some time and go back and plug these back in, which won't take very long, with a calculator to make sure that I did everything perfectly. It's especially important to get in the habit of doing this on homework, so that way when you're taking a test, you remember to go back and check your work. So I have negative 2 times 4 plus 1 equals negative 7. Negative 2 times 4 is 8, plus 1 gives me negative 7. So it works. For my second equation, I have 3 times 4 minus 4 times 1 equals 8. 3 times 4 is 12. 4 times 1 is 4. 12 minus 4 does give me 8. So it works. So I can go ahead and put a circle around my answer. Maybe put a little check mark to show my teacher that I actually remembered to go back and check it. And I can move on to the next problem. If you have any questions, feel free to email me at mbremer@d131.org. Thank you and have a good day.